Section 12-4, Part 2, identifying right triangles when side lengths are irrational. Is the triangle a right triangle? Well, here we have two sides of this triangle that are irrational. The square root of 15 is irrational, because if you take the square root of 15, it's not a perfect square. You don't get just a whole number, okay? If you take the square root of 15, go ahead and punch that in your calculator, and take the square root of 15. When you take the square root of 15, you get something like this, 3.87298, and that goes on and on and on, no repeating decimal. It just goes on and on and on. So this is an irrational number. The square root of 21 is also irrational, okay? So we need to talk about that. So how do we determine if this triangle with irrational lengths of sides is a right triangle? Well, again, we're going to use that converse. If we can prove that a squared plus b squared equals c squared, then we can say that this triangle is a right triangle. So if a is the square root of 15 and b is the square root of 21, let's plug it in. The square root of 15 squared plus the square root of 21 squared equals to c, which is 6 squared. Does the left side equal the right side? That is our question. Now, the reason why I knew that both of these numbers were irrational because they were not perfect squares. Like the square root of 9, we know is 3. Therefore, the square root of 9, this is a rational number. The square root of 16, that's rational because I can take the square root of it and I get a whole number. Any whole number is rational. Any number that can be put in the form of a over b is rational, such as 3/4, that's rational. Now 3/4 were reduced to 0.75. Any decimal that terminates, that stops, is rational. So your perfect squares are rational because you can take the square root of them. But these are irrational because you can't take the square root of them. Now, the square root of 15 squared. When you square a radical, you're saying the square root of 15 times the square root of 15. Well, when you say the square root of 15 times the square root of 15, you get the square root of 15 times 15 is 225. And if you punch in the square root of 225 on your calculator, you get 15. So really, when you square a square root, they just undo each other. When you multiply two radicals that are identical, two square roots that are identical, your answer is really what's inside, okay? So if I square the square root of 21, I'm really saying the square root of 21 times the square root of 21 gives you the square root of 441. But if you take your calculator and you take the square root of 441, you just get 21 is equal to. Now if you square 6, 6 squared is 36. So now the question is, does the left side equal the right side? Well, 15 plus 21 gives you 36. So yes, 36 equals to 36. So yes, this triangle is a right triangle. This example allowed us to work with irrational numbers. Again, numbers that you can't take the square root of are irrational. Numbers that you can take the square root of are rational. When you square a square root, the square root of 15 is really just 15. When you square the square root of 21, you really get 21. Equals to 6 squared was 36. Now you saw me take that process. The square root of 15 squared was the square root of 15 times the square root of 15. You get the square root of 15 times 15 is 225, but if you take the square root of 225 on your calculator, you get 15. Square root of 21 squared is square root of 21 times square root of 21. That's the square root of 441. But if you take the square root of 441 on your calculator, you get 21. Okay? So really, if I ask you to square the square root of 9 squared, the square root of 9 squared is really just 9. Squaring a square root, they undo each other. Because you really have the square root of 9, which is the square root of 9, times the square root of 9, which is the square root of 81, which is 9. So there's the steps that it takes to get to 9. But if you'll just accept that when you square a square root, you just get what's inside. So yes, this triangle with sides, with the legs square root of 15 and square root of 21 and a hypotenuse 6, this was a right triangle. So is the triangle a right triangle? Yes, it is.